Welcome to the fifth section of our course, where we will complete development of our second app. I'm excited about implementing cloud anchors using AR Core Framework and deploying the experience onto Android and iOS devices. Before we commit our minds to the cloud, let's review what we start this section with, reviewing the flow. In this video, we will consider how our application works, what could be improved, implement a few solutions, and make note of what deserves more development time. We have three very clear issues, one with scanning and status feedback, another with the building selection panel, and the third with object manipulation. Also, a quick note, we have updated to the latest AR Core SDK. What hits us when we switch on the app for the first time is no indication of scanning aside from the text. New update of AR Core includes built-in visual feedback from the system, such as warning about low light in real environment. We will now enable plane visualization because we want to start getting familiar with it before the last project of the course. It also helps with deleting buildings by providing us with active field of play. If you search for plane discovery in the project assets, you will find a prefab AR Core now adds to all their sample scenes. It has a canvas with several children. It provides a mini tutorial via More Help window, feedback on scanning via snack bar, and even a little masked WebM video depicting the scanning process. Since we implemented our system step by step, we will not transplant the whole prefab, but feel free to do so if you find it beneficial. It is definitely important to have such entry-level information for people who have never tried AR before. We could reach for another prefab to signal the feedback from the environment using point cloud. The problem, however, is that while the system visualizes points, it does not provide us with a robust enough representation of the tracking because we are dependent on plane detection. For instance, do you remember when in the last section we dragged the buildings far outside of the platform and they would not disappear? We need to approach plane visualization similarly to what we did in AR Foundation at the beginning of the course. This way, we will know the current state of tracking and see where we can drop our buildings. Let's create an empty object in the hierarchy. I will call it plane generator and add detected plane generator script to it. To take a shortcut, we can use existing prefab called detected plane visualizer. The issue we will face if we start spawning this prefab is it will overlap and glitch with our platform. Let's open our detected plane generator script. We see it is made of update function responsible for spawning planes if new trackables are detected. A new plane is initialized at vector 3.0 position, which is the same Y position as of our plane, which we want to keep on the physical surface. Let's declare a new vector 3 variable and lower it by 0.1 floating point so the visualizing planes reside right under our platform. Done. Now let's follow the detected planes visualizer prefab and open the script that sits on the object. We will look into this script in the next project. For now, we will limit the variety of the colors it assigns to new visualized planes. In fact, I will uncomment the whole color array called kPlaneColors and declare a public color variable called gridColor. Next, in the initialize function, I will assign our new color variable to the material.setColor. Save the script. Now you can edit the color on our prefab in the inspector. Running app via Unity Editor Instant Preview allows us to change the colors of the cloned planes. Unfortunately, the touch support is still not there. We also wanted to update our text feedback. It will enable us to refresh the Platform Manager script. First, I will add platform spawn string right after we instantiate the platform. We also need to indicate to the users they need to pick a building from the panel on the left side of the screen. Next, we can add a few feedback notes when a building gets selected, then a new one is spawned. Also, when we are moving and replanting the module. Another useful notification would be about the last module, which we don't want to destroy. All the others can be gone. At the end, we can highlight the object is being rotated. In fact, at the very beginning of our update function, we could check if the tracking is present because if it has been lost, we want to feed the info to the user to know what happened. Let's convert the lost tracking reason to a string. I realize it all might be quite obvious to us, but probably not to everyone else. Okay, now let's proceed to the second issue, the building's navigation area. We originally implemented buttons alongside building models. Users might instinctively click on the buildings, which currently do not respond to interaction individually. Let's change it now by simply expanding the buttons in horizontal axis. we will add a text to our toggle button to make sure people know what it is there for. Now, to other buttons, we will simply extend Rect Transform of the buttons, align them to our scroll view object, next apply slight changes to the position of buildings as well as to the size and alignment of the text. Please remember to reduce opacity of the buttons, otherwise they will cover the buildings. We have an actual bug in our application that is spawning buildings when touching the building panel. In the first app of this course, we prevented it. Do you remember when we wanted to paste the link to our MP3 file and the assistant would move there? In the previous section, we reapplied this event system condition in passing. We need to slightly amend our code in update function of the platform manager script. Before deciding whether we used 1 or 2 fingers in the process, we need to check for the is pointer over game object and pass the finger ID. We could also make the panel respond with a slide when we arrive to its end. Please feel invited to play with the properties of the scroll view panel. You can achieve a bouncy feel to swipe in it. It's the elastic property. We could now have a separate video on rotating the object on the platform. In the previous section, we considered Lean Touch as a relevant package, but did not want to pursue integrating external library. With the new release of AR Core, we have access to newly rolled out manipulation system. Let's look at the documentation of the new sample scene introduced to the SDK. The system covers all critical finger gestures touchscreen users are familiar with: manipulating objects to select them, moving objects around the scene, rotating objects, changing the size of an object, elevating an object. The API is very clear and the scripts are thoroughly documented with concise comments. Due to our rotation issue, we would focus on Twist Gesture Recognizer to implement it in our Platform Manager script. Essentially, AR Core offers here a very succinct and powerful function: calculate delta rotation. We could reapply. This, however, would require several further tweaks to our script that are not a priority at the moment, since we understood the process. Feel free to improve on the interface in other parts of the experience. Always question and think of what could be better in the experience. And on that note, I highly recommend AR Core Elements app, Google shared on the app stores. It playfully demonstrates the degrees of freedom and implements best design practices. This app helps picturing how different elements of AR design can work together. We now have something that can deliver the concept without feeling estranged. As promised at the end of the previous section, in this video we corrected some of the flow aspects of our app. We focused on signaling the state through plain visualization and text feedback, we patched our module selection, and were introduced to a new AR Core finger gesture system. We will now venture into the clouds.